The standard J-pole is a staple for VHF-UHF operations. It is essentially an unfed half-wave vertical dipole that uses a quarter-wave parallel transmission line stub to match the antenna's high impedance to a 50 ohm coaxial feed line. While reliable and relatively ground independent, its gain is modest. When you need more gain and a flatter radiation pattern directed toward the horizon, you move up to Super J and Collinear J designs. Both are collinear arrays that build upon the standard J-pole base by stacking an additional radiating element on top, but they differ in how they manage the electrical phasing between those elements. The Super J-pole antenna. A Super J-pole takes a standard J-pole and stacks a second half-wave radiator directly above it. If you were to simply attach another half-wave of tubing, the RF currents in the top section would be out of phase with the bottom section, shooting your signal up into the sky instead of out towards the horizon. To fix this, a phasing stub is placed between the two radiators. A half-wave piece of wire or tubing folded into a U shape or sometimes bent into a circle, separating the lower and upper radiators. This stub acts as a delay line. It doesn't radiate much energy itself. Instead, it flips the phase of the current by 180 degrees so that the RF energy entering the top radiator is perfectly in phase with the bottom radiator. A well-built Super J-pole can provide roughly 1.5 to 1.8 dB of gain over a standard J-pole, and it typically offers a wider bandwidth, giving you a flatter SWR curve across the band. The Collinear J-pole, sometimes just called a coil Collinear J, is a mechanical and electrical refinement of the Super J design. Instead of using a bulky folded half-wave wire for the phasing stub, the Collinear J uses an inductive phasing coil. The U-shaped stub is replaced by a tightly wound coil placed between the lower and upper half-wave elements. The coil achieves the necessary 180-degree phase shift through inductance rather than pure physical length. In antenna theory, increasing the physical spacing between collinear radiating elements enhances the overall gain. Because the coil takes up less vertical space than a folded stub, you can optimize the physical separation distance between the two radiators. A Collinear J with a well-designed coil can achieve up to 2.6 decibels of gain over a standard J-pole, outperforming the Super J. If you are deciding which one to construct for your station, it usually comes down to mechanical preference. Here is a comparison. Gain moderate for Super J-pole, 1.8 decibels over J-pole. Collinear J-pole, highest gain, 2.6 decibels over J-pole. Construction: Super J-pole is easier, just bending wire or soldering copper pipe. Collinear J-pole, harder, requires calculating and winding a precise RF coil. Wind load: higher for Super J-pole due to the protruding U stub, while for Collinear J-pole it's lower, sleeker aerodynamic profile. Bandwidth is very broad for Super J-pole, while it is only broad for Collinear J-pole. The Super J is often favored for simple copper pipe builds because you can construct the phasing stub using standard plumbing elbows and T-joints. The Collinear J is the superior performer and looks much cleaner on a mast, making it an excellent choice if you are comfortable winding your own coils and securely weatherproofing them.